This calculator would appear on a calculator question. Again, it says use algebra, so you wouldn't be allowed to use your graphing calculator to graph both equations and find out where they intersect. So when we're using algebra for part A, again, I notice that there's a squared in there, co-squared. So that should trigger, either I have to get that co-squared by itself and square root both sides, or I'm going to have to factor. And because this equation also has another cos x, this is going to be one we're going to need to try to factor or use a quadratic formula. So when I move everything over to one side, I'm going to get 3 cos squared x plus cos x minus 1 equals 0. And if the first thing that you try to do is to try to factor, if you could factor this one, okay, I'm kind of hinting that you can't, and it's going to not work. But if we could factor this one, the only way to get 3 cos squared would be to have a 3 cos x and a cos x. The only way to get a 1 would be to have a 1 and a 1. So as far as factoring, if this were factorable, this is one of the easiest ones in the world to factor because there was no choices up till now. The last thing you'd have to decide is what would be plus, what would be minus. But when you look at the outside, which is 3 cos x, and the inside, which is 1 cos x, do 3 and 1 ever make 1? No. So this was our only option, and it doesn't work. So this is telling us that for this question, we are not able to factor. If you're not able to factor a quadratic equation, what's your only other option? Your quadratic formula. Okay? Now your quadratic formula, it's on your formula sheet. It looks like this on your formula sheet. But that was an equation for x squared. We have an equation that has cos squared. So instead of x, we're going to write cos. And then we can go negative b plus or minus b squared minus 4 times a times c all over 2 times a. And simplifying this, negative 1 plus or minus, we get the square root of 13 over 6. Now there's going to be 2 equations that get made from this. One equation is when we use the plus sign. One equation is when we use the negative sign. So to figure out what those values are, we're going to go to our calculator. I'm going to use the fraction button. I'm going to write negative 1 plus the square root of 13, all divided by 6. So my positive 1 is 0.434. Now I'm going to write 0.434 and then just go dot, 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 to show that I'm not going to round any of those answers. Okay? Now, before we do the negative one, how would you work with this? What would you do? Can you solve for x if it's 0.434, or is this one that's not possible? It is possible. How do we know that it's possible? Yeah, that value is less than 1. If that value was bigger than 1, then right away you could just go not possible and you'd be done. And every time I do a quadratic equation 1, I'm hopeful that it's going to be bigger than 1, because that makes my life easy. This is a bad question. I'll warn you already. I think the other one is also less than 1. So we have to do work on both sides. So we've got this. What does this tell us about the angle x? As soon as you get a value, it tells you information. What do you know about the angle? You know that it's in quadrant 1, and what other quadrant? Quadrant 4. How do we know that it's in quadrant 1 and quadrant 4? because this value is a positive value. So we know that it's in quadrant 1 and quadrant 4. Now, depending on where you're at with trigonometry, once you get really comfortable with trigonometry, you no longer have to draw little pictures of quadrant 1 and quadrant 4. You can sort of have those pictures in your head. But until you get to that point, if you're still like, this question is still hard for me, then draw those pictures, because the next thing you're going to find is your reference angle. And you find your reference angle by doing cos inverse of this value. And so we'll go to our calculator and go second cos. Oh, I should check first. Oops. My mode button. Am I in radians? I am in radians. Oh, it does. Nice. There's a little word up there. Not all calculators have that. Only the newer versions. But if you want to check, you can hit your mode button, make sure that you're in radians. And now I'm going to go cos inverse of the answer that I had before. So I can go second answer. And I find out my reference angle is 1.12. So if you've drawn the diagrams, right, that's telling you that those angles, those reference angles are 1.12. If you have it in your head which quadrants it's in, you can just imagine that. But that will then tell us, well, if I want to find x, the one in quadrant 1 is easy. It's just going to be 1.12. If I want to find this one in quadrant 4, well, then I'm going to have to go to my calculator and go 2 pi minus that reference angle, which I have as my answer, 5.16. So those are our two approximate answers for the first one. Again, looking at my notes here, sometimes it's easy to think, oh, I'm done because I solved for x, right? So the way that I've set up my notes, I wrote arrows here. You should see, if you look back at your question, oh, this whole side over here is blank because we haven't done the second one. The second one, right, is with the minus sign. We did the plus sign over here, so now we're going to check what happens when I do -1 minus the square root of 13, all divided by 6. -7, -0.7676759. -76759, ... So like I said before, it's not bigger than 1. So we have to do the same thing again. We're going to have to find our reference angle. But what does that tell us about that angle x? What quadrants will it be in?
2 and 3.
Quadrants 2 and 3. So we can imagine an angle in quadrant 2, an angle in quadrant 3. We're going to calculate our reference angle. So some interesting things here. When we do our reference angle, it's always going to be cos inverse of the positive of this. So if I do second answer, what's the problem here? It's negative.
So what you do is you just times the answer by -1 and then...
Does that make sense? What Peter just said? If we multiply our answer by -1, that will take this -0.767 and make it a positive 0.767. Or you could retype it as positive 0.767 and try and keep all those decimal places in there. So there's some options there. But we do always, with the reference angle, do the inverse of the positive value, because that will give us an answer that is between 0 and pi over 2, or between 0 and 90 degrees. So now we know the reference angle is 0.696. And I'm going to take that answer, and I've shown you the store button before. I'm going to hit the store button and store it as x because I know that I have to use it twice. I need to use it to find the angle in quadrant 2. So here, if this is 0.696, I have to find this angle. And here, if this is 0.696, I have to find this angle. So going to my calculator, storing that as x lets me go pi minus x to find the one in quadrant 2, and pi plus x to find the one in quadrant 3. So x is approximately the one answer, 2.45, and the other answer, 3.84. So now we've solved between 0 and 2 pi. But again, I said that's what we sort of get in the rhythm of doing, right? Once you start solving, you get in the rhythm of finding your reference angle, figuring out what quadrant it's in, writing your answers between 0 and 2 pi. Now we're going to go back and check. Did they ask us to solve between 0 and 2 pi? No. This one said to solve between negative pi and pi. So now we have to go back and think which of these answers actually work and which of them don't. So if we're solving between negative pi and pi, does it make sense that that would include answers from 0 to pi in the positive direction and from 0 to pi in the negative direction, or from 0 to negative pi? So looking at the answers that we have, anything in quadrant 1 and quadrant 2 is going to be the same as what we solved originally. Can you see that this 1.12 is good? And this 2.45 in quadrant 2 is good. But this answer in quadrant 4 and this answer in quadrant 3, we're going to need to instead think of the negative answer. So in this case, the fact that we drew the diagrams is actually going to help us see what we need to do. Okay? So which are the ones that I need to change? I need to change this one. I need to figure out what this angle is as a negative. I need to figure out what this angle is as a negative angle.
I minus 1.16.
This one's the really easy one, right? Because there's our reference angle. So that one's going to be negative 1.12. This one is actually fairly easy as well, because we've already done the math. Because if I wanted to figure out what this red angle is, can you see that I'd have to go pi minus 0.696? Can you see that I did that already in quadrant 2? So this one will be negative 2.45. And now we've solved it for the domain that they gave us. We're noticing, as math teachers over the last couple of years, they tended to go more and more questions like this on the calculator part of your exam. Because there's no way you could solve this without your calculator. They still say you have to use algebra. So they want to see that you can do all of this, right? More and more they've added the quadratic formula in there, and then find all of your answers. Now that we've found our answers, we can go to part B. Part B was the general solution. Now in 7.1, when I introduced you to the general solution, I said the general solution is just solving like normal between 0 and 2 pi. That's the first thing you've done. And we've done that already in part A. And then after you've solved normally between 0 and 2 pi, then you just write all the coterminal angles. And all the coterminal angles are just by adding 2k pi, where k is an integer to each one. So for this one, did we solve between 0 and 2 pi? Yes. How many answers did we get? We got 4 of them. So I had 1.12, I had 5.16, 2.45, and 3.84. And it doesn't matter that I didn't write them in numerical order. Probably in fancy textbooks, If they were doing the final publication, they would probably put them in numerical order, but they're not going to worry about that. So I like this actually because these are the first two that I found, and these are the second two that I found. And then to write all the coterminal angles with each of these, this is where we add 2k pi to each one, and there's our general solution. So the general solution idea stays the same whether they're nice numbers from your unit circle or decimals like these ones that are not on your unit circle. You find your answers between 0 and 2 pi. Then add 2k pi to each one. Okay, questions on this one? This is the order I'd like you to do them. I want you to do 14 first. For 14, I believe most of those ones you can factor. You don't need to use your quadratic formula. 14, then 13, then 12.